So those of you who are unfamiliar with Strayos, maybe you've heard of us, seen the platform in one way, shape, or form. Strayos is really a platform where we create mine-to-mill solutions with AI at its core. And we really develop a lot of solutions tailored to the mining and the quarrying process, whether that's the surveying, drill and blast, geospatial, geotechnical side of the operation, where we encompass all this within one platform. And we use AI for a lot of the processes and automating a lot of the processes within these workflows. And we'll dive into that a little bit more in the platform. A little background about Strayos, it started in about 2016, 2017. We are a global company. We have team members scattered across the globe, as well as our customer base, serving the quarrying, mining industries, whether that's industry metals, precious metals, aggregates, cement, and so on. So we've grown pretty steadily since, and we can offer a live 24/7 support with those customers, with Strayos being a cloud-based platform. And we're constantly improving based on that customer feedback and the input that we receive from our user base. So I want to take a few minutes and talk about what the workflow in Strayos really looks like. And it's all really going to start with the data collection. Within Strayos, we have our own proprietary photogrammetry engine. And with that, we can produce 3D models based on imagery that's been taken from the field and from the users. The way the software is set up is where users can come in, upload that data, whether it is imagery, Lidar, any sort of terrestrial scan. As long as it's geospatially referenced, we can model that and conduct a lot of these analysis and tools through the platform. In this workflow we see here, by collecting the images and creating that 3D model, we can do several different analysis and accomplish several different tools through the geology analysis, our drill and blast planning, designing our loading, our timing, and looking at some prediction models, whether that's fragmentation, muck pile prediction, vibration and air blast prediction, all on the drill and blast side. Now, when we bring that more to our pit and surveying side, we can also apply AI to auto-detect our haul roads, whether it's the grades, the inclinations, the berm heights of those roads, or our high walls, where we're doing crested toe detection, where we can then start looking at our bench heights, our face angles, inter-ramp angles, catch bench widths, all within the platform. We can input and extract that data in several different ways. If you're bringing in layers or maybe different surfaces to overlay to those models, or you want to extract it to another mine planning software, we really created one environment where you can do all these tools in one. Furthermore, we do have a lot of compiled reports that are automated from the different modules you'll see. These reports are really meant to collectively show this information in a very smooth manner, and of course automating that process. So being able to get the data, process it, conduct the analysis, and report the results in a timely manner, saving time from bouncing from software to software or saving time in the field, is really the goal here. So as I mentioned, this is one platform, but it's very modular, where you can use a lot of different tools within the platform, whether you're doing your drill and blast design, or maybe you're doing your pit surveys for updated topos or stockpile inventory flights, or any geotechnical analysis. You can really do this in one platform, which brings a huge value to the end user. So diving into some of the newer product updates that we want to focus on in this session today. First of which is incorporating geological models, whether that's block models through IFC files, onto now your 3D models. With that, we also updated our management of these layers and annotations or measurements through a folder structure. So when you do have several different design layers or several different geological models that you're uploading, it makes it very easy to organize this. You can see on the image there on the left-hand side, the folder structure that you can then organize these files into. With this now, you can do any measurement and design work with these uploaded files, similar to what we had before, but we just expanded that range of accepted files now, especially on that block model reference. So we also released a new model. This is our slope stability AI, and this is something we've been working on for a little while, and are happy to put out there now. And it's really encompassing as you can see here on the description, AI as well as a physics model and the 3D model that's created in Strayos. And what we're doing is we're calculating the factor of safety based on the model itself and the material properties that are inputted by the user. And what we're doing here is using methods of limit equilibrium, as well as a modified Bishop's equation for circular slip failure. So in this case, based on that model, we can look at that data from the input from the user on the material properties, as well as the DSM and even the rock mass data here to really show the factor of safety rating for that area of the pit. And you can see in this case here, the heat map showing the different factors of safety ratings there. And we'll look at this another example in the demonstration. So another new feature that we want to highlight here, in addition to what we already had, is our fragmentation prediction. So in Strayos, you can accomplish a fragmentation prediction by designing your blast, applying any loading or timing to that, and then any rock properties you can see kind of on the upper left image. What we're going to look at are the powder factor, Young's modulus, compressive strength, your pattern itself. A lot of those factors are going to play into the equation here, but we've also now added the addition of rock mass parameters. So now whether your rock, let's say you have in the image, reference image on the right, for example, intact or massive areas in the rock, or maybe it's very blocky or seamy, we can now incorporate that data in our fragmentation prediction, giving that much more input for hopefully a more accurate result on your design. So again, we'll dive into this into the platform. Just want to give an overview here right away, and we'll go ahead and do that next. So we should be seeing my Strayos tab open. Mateo, give me a thumbs up once you see that. It should be popping up here. Perfect. So this is just an example. I wanted to continue that presentation where you can see this folder structure where we can organize a lot of these design files now. And what this allows us to do is once we upload that design file, we can then push that to several different models within the platform. For example, here we're looking at a 2D model of a site. And if we go to the 3D, we can see that here as well. And what I can do is with those IFC files or geological models, we can overlay those onto our 3D model here. So this can really allow us to visualize the structure, any of the geological changes in our pit, maybe having a factor on how we design our next blasts or our operations in that pit. Really being able to do this in one platform can bring a lot of value. So I want to touch on another function with the DXF designs, and that's where we can input this for maybe drill and blast designs as well. So as I mentioned, we did change this recently for the Strayos users that are on this webinar. Beforehand, you would have seen annotations and layers here at the top. Now we have measurements and design and layers, I should say. The annotations are now what we'll call measurements. That's going to be our volumetric tools, our 2D and 3D measurements. These are all going to be considered measurements, and we'll see them saved here, where again, you can create a folder structure to organize those. Now, as far as designs and layers, this is where we can upload different designs, whether that is DXFs, IFCs, any imagery or PDFs that we want to overlay to our model, geographic data, any georeference drawings, or maybe point measurements or CSV points that we surveyed out in the field. We can now bring those onto the model. By uploading these, it's at a site level. So now you can push this to different projects within the site very easily, instead of having to upload numerous times through different modules and different projects, which we had before. So again, should save a lot of time to those who are uploading different file types to their sites, making it a lot easier to conduct the analysis that they're looking to do. In this case, I wanted to showcase the example, for example, with the high wall data. If we have a pit design or a pit plan that we want to overlay, in this case, I have chosen a design. We can choose from our design files here. once that's chosen, what we can do is view a design crest and a design toe. We can also start looking at some of our compliance checks, whether that's overbreak and underbreak, catch bench capacity, all based on our design. Now, something else I want to touch on here with the design is with our drill and blast planning. And a lot of times, whether you're doing any ramp development or just development work in the pit itself, and you have a design surface that you're looking to design your model to, or your actual ground conditions to, we can upload that design and use that as a floor elevation on our drill and blast design. So in this case, I do have a design, and I can showcase that here. Go back to our designs and layers. So here in 3D, we can see a completed pit shell. This is what I'll be referencing for our drill and blast design. So in this case, when I create that drill pattern, I'm going to be able to choose my design floor. And you can see here, there's an option that allows me to choose from that design. So in this case, I'm going to choose that DXF. And once I hit apply, it's going to use that DXF for my elevation. So we're at the floor level here, so it's using that as the floor, but it's going to bring a lot of value. And in fact, if I do have a ramp and I want to design my holes and my cut depth specifically to that angle of that design file, we can do that with the upload of that design file. So for those of you who are users already and have any questions here, feel free to reach out further, and we'll be happy to help you upload files. If you have any issues with the design, obviously reach out to us. So I now want to transition to the slope stability. This is where I mentioned in the presentation, it's all based on the factor safety and the material properties that are entered by the user. So we can see here under slope stability AI, this is new. So it's available for users to test out, provide feedback. Of course, we're always looking to improve. And I have a little test area here from a site where the user now can come in and they're going to have to define their area of interest. So once they draw that AOI, what we need to do is add a material. So in this case, depending on the material, right now I plugged in a gravel with sand mixture. We're going to need the density, the cohesive strength, and the friction angle of that material. Based on that, it's going to calculate for that one area that you choose. And what we'll be able to do is view the factor of safety. In this case, areas in red, or that factor of safety is less than 1, tells us that that slope or that area there is on risk of failure, I'll say. Whereas once that value climbs greater than 1, that factor of safety increases, that chance of failure reduces. And we can see here in the legend what those values are representing. As I hover over the map, you'll kind of see the values that are shown. Anything that's not shown is exceeding that 1.5 range. So in this case, that lower section of the slope. So this gives us a really good visual and a really good quick analysis on the factor of safety of the slope within our pits, whether it's, depending on the material type. If we get those material properties in there, you'll be able to produce this based on your 3D model and also produce the report as well. Within Strayos, I mentioned a lot of the automated reports. You'll see this format on several of the reports. We'll have our cover page and usually some options you can add on the left or the right-hand side. And you can orientate these in whichever direction that you're looking to produce on the report to then generate and share within your organization. So the next topic I want to transition to is that fragmentation, the new prediction that we've come with. So in this case, I wanted to highlight some of the rock mass analysis that we can do within the platform that can then correlate to our fragmentation prediction. So in this case here, I have a 3D model of a bench design, and you can see our rock mass AI. And what I can do here is similar to our slope stability, I can create an area that I want to run the analysis on. So in this case, you can see I have 4 separate areas where the rock mass AI is detecting what we call facets and seams. And we can see that here in 3D, where the facets are the faces or the planes, and shown in the green rectangles, in their orientation based on their dip and their strike. In conjunction with that, I also have my seam detection. So we can see here as well, looking at the model itself through the point cloud, the DSM, and the photogrammetry, we're detecting these features and discontinuities using the AI. Within all the AI functionalities in Strayos, there is some user input that they can manually adjust things or add things or erase things if they need to. In this case, users can edit the rock mass by adding facets and seams if they need to, really fine-tuning that data. So what we can take from this data is then looking at our fragmentation prediction with this accounted for. So in the event that I do have a drill design that's completed, let's say here on this open den, once that design is completed and it's been loaded and timed, what I can do is go to my blast prediction. And what we'll see here is our fragmentation prediction. Now, when I select that, you'll see the parameters that show up on the left by default. This is going to be our bench height, our burden, and our spacing, any inclination, our hole diameter, any drill area that we want to account for, our charge length, our powder factor, our relative weight strength, hole delay, P wave, Young's velocity, compressive strength. So these are all going to be factors that come into play by default. But now additionally, we have our rock mass parameters. And this image is what I also shared there on the presentation. This is where it's going to utilize the 𝘙𝘂 and we can then identify whether we have maybe a blocky or powder pliable massive sections of our rock, our joint spacing, which we can calculate through that rock mass. So if you run the rock mass analysis, you'll obtain that joint spacing where we can then apply that here. And also we can show whether we're dipping out of the face, our strike is parallel, normal to face, into the face, depending on how that rock is laid. We can account for that here in the fragmentation prediction. And you'll see how the values are changing here on the right, depending on how I change these parameters here on the left. We'll also want the density of the rock mass, so I'll have a factor here as well to really get that fragmentation fine-tuned to your specific shot. Now, what's unique with Strayos and the AI is this is a constant learning loop. So as we start adding post-blast data of fragmentation results, what we can do is use that and calibrate it to the site. So it's always going to improve based on the data that you plug into the software. In this case, if I start shooting, let's say shooting this bench back, I fly my blast post-blast to measure the fragmentation analysis. It's going to use that and then start learning from that for my future predictions. So in that case, I can really start getting real accurate fragmentation predictions. If you're looking to reduce fragmentation or have fragmentation as a KPI, reduce fines, or really monitor that value, this will be a powerful tool for users. So lastly, I also wanted to add with our some of the updates we have throughout the platform, when users are looking to PPK data, what we've done is we allow users to upload their local base station files to PPK their data. I know we hear a lot about RTK processing now and PPK. With a project creation, we can now accommodate for those base stations that you may have on site with those RINEX files, upload that with your timestamp and observation file from your drone, and we can post-process that. So it's another option for those who are looking to properly georeference their models. Whether they're not using RTK, they struggle using RTK in areas, PPK is a very good alternative and a trustworthy method of surveying here to properly georeference our models. So just another option there for users who are maybe already using Strayos or those who are trying to learn more about it. Provides another avenue for uploading data. So I know we've gone through that pretty quickly. I know I wanted to leave some time for Q&A. It was an hour scheduled here. I don't think we're planning on taking up all of it. If there are any questions, I don't know if we want to start going through those and
Yep.
we'll kind of open things up.
That's perfect. Thank you, Eli. There are a few questions here that were posted. Keep posting if you would like. So there is a first question here by Jack from Jack that says, "What is the reference for the joint plane spacing table?"
The joint in the presentation?
I believe so. Yes.
Yeah, yeah, we got it from a published paper that we can provide. As needed.
Okay. Then the second one from Jack is, are examples for slope stability rock or soil?
Yes. So I showed one with soil. You can apply it in rock as well, as long as you have the material characteristics. That has to be inputted by the user. As long as those are known, you can apply it really in all cases.
Thank you very much. Then there is another question from Charles that says, timing loading product IS drill hole QA and QC, including fragmentation prediction?
So fragmentation, so yes, it's going to account for those parameters that were shown. Any changes in the burden or spacing, for example, will be accounted for in the prediction, as well as that drill error that can be accounted for. So it's all going to be pulled from that design. And if you have any QA, QC drill data, it will account for that there in the prediction model.
Thank you very much. Then we've got a call. Well, someone that loves the new PPK function, which is great. Thank you very much for that comment. Then there is a question from Mark. He's asking, you said we can import block models. How many variables can be included and are they displayed in Strayos?
That's a great question. So far, I haven't seen a limit. We may have a capped limit there I could check on. As far as I've uploaded some with several, we'll have to revert on a limit if there is one. But as of right now, I don't believe we do have limits.
Okay, thank you, Eli. Then we've got a question from James. For slope stability, if I have two data sets, one from a UAV and one for a terrestrial LiDAR system, each has different accuracies. How is this accounted for or documented in the software? Have you done any testing with this?
Yeah, so this is a brand new module we just released. So we are continuing to do testing. It's all going to be based on that point cloud data and the density of the point cloud, whether you're doing the scanner, LiDAR, or photogrammetry. So it's available to use. I would encourage you to, if you are a user of Strayos, test it. Provide us feedback. We are doing ongoing testing here. It's available to use. So we're definitely open to improvements here.
Thank you, Eli. We've got another question here. Is the prediction AI module linked with your cameras and measure fragmentation at crusher or conveyor? Maybe you need to give a bit of context there for regarding the crusher and conveyor side of things.
Yeah, not a problem. Yeah, so I know we didn't cover it in the presentation here. Strayos is a software company, but there's one piece of hardware that we do provide, and that is real-time fragmentation monitoring through a 3D stereo net vision camera. Feel free to reach out to our team about more information on that. But yes, we can link the data from the web-based fragmentation drone data to that camera as well. Be happy to provide more information on that as needed.
Super. We got another question here from Jack. It says, is the software set up to handle non-L and electronic detonation systems?
It is. So within the drill and blast module, what we can do, and we already have it in the software already, the manufacturers and the products they produce, specifically the bulk emulsions, non-L electronic initiation systems, all the proper cap lengths, densities of products, that's all going to be in the platform. And we can always add products as needed if we don't have them, if it's something you're using. So happy to help there as well. But yes, we can accommodate for non-L and electronic timing with all the and products being used.
Thank you very much. Then we've got a question here from Carla. Thanks for the presentation. Thank you for attending. For what I understand, fragmentation prediction is based on the 𝘬𝘗 model. What are you using to correct fine predictions?
Yep. So we have it's 𝘬𝘗 and 𝘬𝘭𝘰𝘁, and we also have a fines factor adjustment. The fines factor is really a ratio between 0 and 1, where you can adjust what we're calling the fines factor based on what you have for fines in the pile. And I like to give the example of, the voided space within that pile, how much of that is actually fines. In the example with aerial photogrammetry and fragmentation analysis, Strayos is detecting fines on the top of the pile. You're not going to see any particle detection there. It's going to be essentially just there's no detection of particle sizing, so we're not going to accommodate in the fragmentation measurement. Based on how much area of that isn't detected, we can then recommend a fines factor. So this fines factor can be adjusted based on the data set to accommodate fines properly within the prediction and also the post-blast measurement.
Thank you. Then we've got a question from Ashland. Are you able to do material cast prediction?
We can. So we do have a cast with a muck pile prediction and cast analysis where we can, once you have that cast angle, we can show volume below or above that spoil line or that spoil pile. So based on that, for example, if you're doing a cast blast on a coal line, for example, setting that angle, you'll be able to see a predicted muck pile based on that design, the loading, the timing, of course, and what you set for that cast analysis.
Thank you. Then we've got another one from Ryan. Is it possible to export electronic hole timing data to blasting systems, Orica Dyno or Davetronic, etc.?
So currently we have an option for Hanwha Hydronics we can export to. We've done you can do a CSV export to some of the other systems, but still developing some solutions there. Feel free to reach out to us if there's something specific that you are looking for, and we may be able to help you there.
Thank you very much. Next question is from Peter. When looking at the blast phase where you map the discontinuities, while this is only one slice of data for the blast bench, can you look at the bench in context of the geological model as well?
So yeah, you'd be able to overlay the 3D geological model the geologic model on the 3D model itself as a layer. I hope that answers the question all right. As far as viewing it in the rock mass analysis, the rock mass tool within Strayos itself is going to allow you to view the rock mass details. As far as overlaying the geological model, you'd see that more as a layer. So as far as seeing them simultaneously, you would be able to see the IFC file on top, but you'd be able to see them in the same project. I hope that makes sense to Peter.
Thank you. Then we've got Martin. Does modeling consider an average borehole density of bulk emulsion or a density gradient?
So the density of the product is always going to be from the material properties of that product that we have. So whether it's from the technical data sheets from the manufacturer, whatever that product is for a specified density is what we'll have in the platform. Users can adjust that density. For example, if your anfill blend, if you're using a gas emulsion, you can adjust that density. However, we're pulling it right from the manufacturer. So unless you are changing that, that's what we're going to default the value to. I hope that answers this question okay.
Thank you. Then next question, how many Strayos AI modules are needed to provide effective fragmentation prediction?
So we have fragmentation prediction is an AI model. Within that, there are different algorithms working. The exact count, I don't know if I can get to you at the moment, but the fragmentation is an AI model of itself. So I guess the short answer is one, but within that, there's probably a few others helping it. So.
Very good. Then we've got a question here with a compliment from Jack. What's been the highest impact / most valuable AI tool Strayos has built and released so far? Then that goes to you, Eli. It's really great presentation and awesome tools.
Thank you, Jack. I would say it is very use case dependent. I would say the simple things such as the crest and toe detection is really helpful, and just getting the automatic bench heights and face angles. That's a really good tool, but also the fragmentation prediction. That's a very good, valuable tool as well, especially with the additions we've just made to it. So You know, personally, simple things that really save a lot of time on the user end, especially myself as an ongoing user. You know, AI GCP detection, for example. If you're flying your large site with several GCPs, being able to have the AI detect that and tag that for you can save you lots of time. So very use case dependent, but those are some of the highlights I like to mention here. Again, to save time really is really the goal at the end of the day here.
Very good. Then we've got one question from Manish. What are the rock mass properties required as input for a blasting model?
So for the blast model, so the design, you can design on any model here to obtain the fragmentation prediction. You can kind of see the rock properties there. To answer your question, there's nothing you have to input for rock properties to do a design. It's all going to be based on the model here. And then for any fragmentation prediction, you'll see the parameters that were on the left-hand side there, whether it's the burden, the spacing, Young's modulus, compressive strength of the rock, and then some of those joint plane spacing and characterizations that you can then plug in addition for the fragmentation. But just to do a drill and blast design, it's just dependent on the model itself.
Very good. Thank you, Eli. Jack, we all know the software will produce an answer regardless of the input data right or wrong. What kind of checking for the final model do you use to feel confident of the software results?
So I'm assuming this is, I don't know if this is tailored to one specific model. You know, I maybe ask Jack for a little more information on that, if it's maybe with the fragmentation predictions or if it's with that's something else we may have covered in the presentation, but maybe revert back to Jack there.
Yeah, Jack, if you can eventually just enter a few more details, so we can you can guide us with where, and we can help you with that question. And then I would say the last one that I see here, more on explosive density, can it recognize distinct loading densities such as a bottom charge, middle, top, etc.?
Yes and no. You can, in that case, I would it's not going to do variable density within the specific product you choose. You'd have to essentially do some sort of deck design there. But I'd be happy to kind of look specifically at that case with the user. We may be able to help them with that there.
That's super good. And I think we are now, we've covered all the questions here. And one thing that I'm going to do, it's also to put our emails in the chat box here, so that if someone wants to contact us after the session, you can do that with no problem. So I'm just including here the email of Eli's, which is ELIJAH@strayos.com, and likewise my email is Matteo@strayos.com. So Matteo is MATTEO @strayos.com. I was included here in our chat. Okay, so without further ado, thank you very much for today's participation. It was great to have you here. If you have any questions, please do contact us either through myself, Eli, or also info@strayos.com, and we'll be happy to assist you.
Thank you. Thank you, everybody.
Thank you.